Hi everyone, welcome back. Today we are going to see about the Kirchhoff laws. So the Kirchhoff law is derived by Robert Kirchhoff. That's why the law is called Kirchhoff's laws. So normally there are two types of Kirchhoff's law. One is Kirchhoff current law, another one is Kirchhoff voltage law. So the Kirchhoff current law it states that in a junction or in a node, that is the main point. In a junction or in a node, the sum of entering current which is equal to the sum of leaving current. So here at a particular junction, the current which is entering, which is current which is leaving, both are equal. Or it may be called the algebraic sum of current in a junction or in a node which is zero. The algebraic sum of current at a junction or in a node is nothing but zero. So this is nothing but Kirchhoff current law. Okay. And the Kirchhoff voltage law. So in a Kirchhoff voltage law, here it's the sum of potential rise, in a circuit, in a closed circuit, the sum of potential rise which is equal to the sum of potential drop in a circuit. So potential rise is equal to potential drop, or it may be called the algebraic sum of voltages in a closed circuit is zero. The algebraic sum of all voltages in a closed circuit within a loop, it must be equal to zero. Okay, so these are the two laws of voltage law and as well as Kirchhoff current law. Okay, and what the voltage division rule it denotes? Here the voltage division rule, so it is with respect to the without load as well as with load, whatever it may be. Okay. So here the voltage division rule, in order to determine the voltage across the resistor. So here in order to determine the voltage across the which is equal to, so where we have to determine the voltage, we have to determine the voltage across R1 or R2 or any other specific resistance. So therefore, which is equal to the total supply voltage, the total supply voltage into same branch resistance divided by the total resistance of the circuit. So this is the formula which is used to determine the voltage across the resistance by using the voltage division rule. And the current division rule. So the current which is flowing through the particular branch or particular element, so which is calculated by using the formula which is equal to the total current which is supplied by the battery, the total current which is flowing in the circuit into opposite branch resistance, that is other branch resistance divided by the total resistance of the circuit. So if you are using this formula, we can able to determine the current which is flowing through all the resistance or all elements of the circuit. Okay, so the procedure for applying the rules. So here the number first one, assume all voltage sources and resistance are given. If not, label them V1, V2, R1, R2, etc. So here by labeling each branch with a branch current I1, I2, I3, it may be called branch current or it may be called as mesh current. Apply junction rule at each node. After that, apply the loop rule for each of the independent loop of the circuit. And finally, solve the equation by using equation solving method or delta Cramer rule. So these are the procedure while we have followed. And this is the assessment. Here determine the value of current flowing through each of the resistor. So in this circuit there are three resistors are available. One is a 10 ohm resistance, another one is 20 ohm resistance, and the third one 40 ohm resistance. So the circuit it contains two meshes. There is nothing but two meshes. So by applying the Kirchhoff voltage law, by applying the Kirchhoff voltage law. So there are two equations for all the meshes, so that you can able to determine the current through all the branches. Okay, and this is the solution for this assessment, and these are the few references for this topic. Thank you.